You might come across this question in your next exam. Here is exactly how to solve it. If 1 mole of aluminum contains 6 times 10 raised to the power of 23 atoms, so that's given. We'll make use of Sam's relation here, straight to the point. So Sam's relation is what is given times what we want over what is known from what is given. And so if 1 mole of aluminum contains 6.10 raised to the power of 23 atoms, that's what is given. So we'll write it here. 6 times 10 power of 23 times of aluminum, comma, how many atoms are contained in 0.9 grams of aluminum? That is what we want. So what is given is 6 times 10 to the power of 23 atoms. What we want is 0.9 grams, then over what do we know from what is given. Please note that for every one atom of aluminum, the atomic mass of 27 is actually what we know from what is given. So here's it. So for every 6 times 10 raised to the power of 23 atoms of aluminum would get 27 grams or grams per mole, which is actually its atomic mass. And so I'm just going to put here. So what is known from what is given will be 27. I'll go again. If 1 mole of aluminum contains 6 times 10 raised to the power of 23 atoms of aluminum, that is written there as what is given. How many atoms? How many? That's what you are asked to solve for, which is what we want. The W there represents what we want. So how many atoms are contained, which is 0.9 over. Now, what is known from what is given is always a constant, and that is our 27. Next, if we point to our calculator, going forward, I would say, I'm with my calculator here, 6 times 10 raised to the power of 23 times 0.9 divided by 27. You'd arrive at 2. So your final answer would be 2 times 10 raised to the power of 23 atoms. And this is your final answer. So the correct option is option C. So option C is our correct option. Would you like to solve similar questions? Click on the link in the description box. You win. Just believe.